Well, this podcast that I'm going to do is going to also deal with Section 8.2 on fundamental properties of area. What this one's going to cover in particular is how to find, for the lack of a better term, the area of funky looking regions. I made one of those funky looking regions here. If you look, I've got this little thing. It just looks like, I don't know, kind of looks like Yoshi to me a little bit. But the way we find the area of this is one way is we could take this region and split up in a bunch of little rectangles. So one way to do it, and again, there's not one way to split this up in a rectangle. Some ways make more sense than others. So what I'm going to do is on this top here, I'm going to draw a segment between here and here. Nice little dash thing. So I'm going to cut that rectangle off. This thing looks like it's something I could cut off, so you know what? I'm going to do that. Okay, so I got that cut off. And let's see. Maybe I'll just cut it off right here too. Again, this definitely isn't the only way we could cut this into pieces. This is just one particular way. Okay, so now all we have to do is find the areas of these four different rectangles. And if we look here, the way I've got my axis, this is going from the y coordinate of 12 to the y coordinate of 14. So this top rectangle that I've cut is too high, and it's going, the x coordinate's going from 5 to 15, so that's 10. So this is a 10 by 2 rectangle, so the area of that top little triangle is 20 square units. And I'm just going to write a little label here. I don't know if you can see it or not, but that's going to be 20 square units. Okay, then I look at, maybe I'll find the area of this region here. If you look, this is going from 0 to 5, so it's 5 long this way by 8. So the area of that little region there, this is 40. Okay, and here I'm going from 5 to 15, so that's 10. And from the y coordinate it's going from 0 to 12, so I've got a 10 by 12 rectangle, so that's the area of that one's 120 square units. So I'll just slap a label in here. And then this last one here, it's going from 15 to 20 here, so it's 5 long, and then going on the y-axis here, going from 6 to 12, that's 6, so it's a 6 by 5 rectangle. So the area of that one's 30. And then, being technical here, the little additive property of area under area postulate, the way we find the area of this region here is we just take these areas and add them up. So I've got 30 plus 20, so that's 50, plus 120, now I'm up to 170, plus 40 more, that's 210. So the area of this little lovely region here is 210 square units. Okay, now again, that's not the only way we could have cut it up. Again, I could have cut this the same way down the top rectangle. Maybe I went from this point right here and cut it all the way over to here, and maybe cut this one here and go all the way across and have a few more different rectangles, but regardless how I cut this thing up, I should get 210. Now that's one way to do it. Okay, slightly different way to do it is instead of adding all those rectangles up, what I could do is basically look at this big rectangle here. If I were to complete this, okay, so if you look at this, I've got basically one gigantic rectangle, and what I could do is cut the areas of this rectangle in the upper left, this rectangle in the upper right, and this rectangle in the lower right out of it. So if we do that, if you look at this big rectangle, it's 20 by 14, so that's 280 square units. So the big one's 280. Just a little note, I'll write it over here. The big one's 280. Okay, now we got to find the areas of these three smaller rectangles here. So if you look here, it's 5 by, let's see, going from 8 to 14, that's 6. So 6 times 5, that's 30. That's 30 square units. The one on the top here, this is 2 high by 5, so this is 10. So we write 10 here. And then the one in the lower right, it's 5 wide by 6 high, so this is 30. So the total of those extra rectangles that I kind of tacked on here, we got 30 plus 10, that's 40, plus another 30, that's 70. So to figure out the area what's left over, I take the area of the big one, which was 280, subtract the 70, and what do you know, I get 210, which is exactly the same thing as I got over here when I cut it up this way. So either way that makes sense for you guys to do, I'd advise to do it. It doesn't matter, you'll get the same answer either way, but basically the gist of it is you look to see if you can cut something up into rectangles and add them together, or if it makes more sense sometimes to find the area of a big rectangle and just cut a couple of little rectangles out of it.